Today we'll start looking at another type of function. We've already tackled functions like linear functions, absolute value functions, quadratic functions, and polynomial functions, so we know the characteristics of a function itself. The specific type we're going to start looking at today is called an exponential function. In terms of vocabulary, exponential function is a function where the variable is in the exponent. And so it's in this form, y equals some base raised to that exponent x, so y equals b to the x. So let's take a look at some examples of what these functions will look like and how we'll go ahead and put together a table of values for them. So our first example is f of x equals 2 to the x power, so y equals b to the x. Our base is 2. We're repeatedly multiplying 2. So let's raise 2 to the negative 3 power. Remember what that means is that means 1 over 2 to the third, so that's 1/8. 2 to the negative 2 is 1 over 2 squared, that's 1/4. 2 to the negative 1 power, right, is going to be 1 over 2 to the 1, that's 1/2. Anything to the 0 is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third is 8. Okay, so now we've got 7 points that would live on this graph, and we can go ahead and plot those points. So let's start with some of the ones that are a little bit easier to work with. So if x is 2, y is 8. Let's plot that point. I'm sorry, x is 3, y is 8. When x is 2, y is 4. X is 1, y is 2. When x is 0, y is 1. We got 1/2, 1/4, and 1/8. So we can see that this gets closer and closer and closer to the y-axis. This value, though, is never going to be 0. It's going to approach, it's going to get really, really close to 0, but it's always going to be 1 over some value. Meanwhile, as x gets larger, this number gets bigger and bigger and bigger really fast. If we go 1 more over, at 4 it's 16, twice this amount. At 5 it's 32, twice that amount, and now I'm off my page. Let's take a look at another example. F of x equals 1/2 to the x power. Okay, so think about what's going to happen here. When we go 1/2 to the third power, that's 1 over 2 to the third, that's 1/8. If we go 1/2 squared, that's 1 over 2 squared, that's 1/4. 1/2 to the first is 1/2. So you can already get the idea of what this graph is going to look like. Anything to the 0 power is 1. Now, when we have 1/2 to the negative 1 power, that's 1 over 1/2. Remember, this is what a reciprocal means, right? The inverse. So 1 over 1/2, I'm going to invert that, and I'm going to get 2 over 1. If I have 1/2 to the negative 2, right, that's 1/4 inverted, that's 4. 1/2 to the negative 3 is going to be 8. So look what happens to this graph. At negative 3, it equals 8. At negative 2, it has a value of 4. At negative 1, a value of 2. Then 0, 1, 1/2, 1/4, 1/8. So you can see that when I have a value greater than 1 that's being raised to a power, as that exponent gets smaller, the value of the function gets smaller, smaller, smaller. As the exponent gets larger, it grows really, really fast. When I have a value between 0 and 1 as my base, when that exponent is negative, it's much larger. When the exponent is positive, it gets smaller increasingly. So let's see what happens just when we plug in some different values. F of x equals 4 to the x power. If I do 4 to the 4th, okay, so 4 times 4, that's 16, times 4 again is 64. 64 times 4, 256. 4 squared is 16. 4 to the 0 power, that's 1. 4 to the negative 4th power, that's 1 over. 4 to the 4th, 1 over 256. What about when we take 1/4 to the x? Looking at this, what do you think should happen here? Now we're using different input values here, but 1/4 to the 3rd power, that's 1 over 4 to the 3rd, that's 1 over 64. If I put 1/4 to the 1st power, that's 1/4. 1/4 to the 0 is 1. And to the negative 1 power, that's the inverse of this. Remember, that's what reciprocal means. So 1/4 to the negative 1 is 4. So you can see as this exponent value is larger, more negative, the y value gets larger. As x is a higher positive number, this value gets closer and closer and closer to the x-axis. Let's take a look at a different one. This one is a value called e. And in the notes, we found out that e is a constant. It has a value of about 2.7. And we're raising it to the negative x power. So you're actually going to take out your calculator for this. Remember, if you take your phone calculator and you put it in landscape format, that you've got a scientific calculator there, and e to the x, that button is actually right on your scientific calculator on your phone. So when you raise e to some negative power, right, you'll be able to punch that in. So let's do e to the 0 power. Okay. So anything to the 0 power is 1. Okay. Let's clear that out. See what you're going to do here. You're going to take the value, right? You need your inverse value punched in a 2. So we're going to hit the plus minus sign, and that's going to give me negative 2. And now x to that value, 0.135. Let's clear that out. Try that again. How about if I have 6, negative 6 as an exponent? E to the negative 6. 0.02. One more time. If I have 10, I want to make that negative, and I'll raise e to the negative 10 power. Get a really, really small number. A number that's too small really even to think about. But as we can see, that as this value is going to get more and more negative, it's going to get closer and closer and closer to 0, but it's never going to be 0. So this is a quick introduction to graphing exponential functions. On the back side of this, after you get done taking a look at the slide deck for the notes, I want you to go ahead and write down 3 things that you learned today from the slide presentation. I want you to read 2 things that you're interested in and want to know more about, and then one more big question that you have.